Okay, what we're going to do is we're going to take a look at this push button and use our multimeter to talk about resistance theoretically. Okay, so what we have right here is the lab volt push button. You'll be using this quite a bit. If I look at the designation here, we see that there's my symbol for the normally closed push button. And when I push this, it would close this side, so that's a normally open. So this is a closed and an open contact designation here. So it looks like 1 and 2 are closed, and if I can look right here, I see the 1 and I see the 2 right here. So the 1 and the 2 are closed on this, and the 3 and the 4 are open. Okay, so what I'm going to do first of all is I'm going to take a look at this with my meter. So in order to see how this is working, I want to set my meter to continuity right here, and I always check continuity to be sure that I'm getting tone, just in case the batteries are dead or something. And I've got tone. Okay, so if I go and I check the open right here, this button is open, and you can see on my meter that I've got OL, and that means that I don't have any connection here. I don't have any tone. Okay, so the first thing to think about is that when we consider theoretically the resistance of a push button that's open, we're going to say that resistance is infinite because there is no current flowing. So right here, there is no current flowing on this. Okay, when I go ahead and I push my button right here, I'm getting tone, so it's making it. Now let's just see what the resistance is when I push that. So it's going to go to resistance. I don't have any resistance right here. It's not reading any because we're considering it theoretically to be infinite across there. And when I push it and I'm going to hold it down, I'm getting 0.2 ohms. Okay. Now theoretically, this should read 0 resistance because I've closed it and there's no load here. But we do read 0.1 or 0.2. It's jumping around a little bit. Why is it jumping around, and why is it not reading exactly 0? Okay, the reason is, there's 0.1. So the reason it's not reading 0 is because we do have some things going on here. This lead right here and this lead, they might have a little bit of resistance in them. The contacts in here might be generating a little bit of resistance. The meter itself could be factored into this, okay? But theoretically, when this gets closed, in a closed situation, and although it reads 0.2, theoretically, we would want it to read 0. Okay? And just for the heck of it, what we can do is we can take these leads out right here. And what about the meter itself? If we just check the meter itself and plug the meter, right into itself, it's still trying to read just a little bit of resistance. Once again, we have some components in here, but theoretically, it would be 0 ohms. Okay, so we're going to check the normally closed contact here, and that is the red one right here. And so we'll just check with continuity first. So go ahead and make my circuit, and it's beeping. And when I push it, then it opens. Okay, so that's the way that this button works, is it changes state when you push it. Okay, let's just check the resistance. This is a normally closed. So in the normally closed position, it should be theoretically 0. It's reading a little bit like we talked about. And when I push it, it should go open. And once again, theoretically, infinite resistance at that point. Okay? So that's kind of the way that we're looking at this. Now, a couple other things I want to talk about is what my circuit is here, okay, in my truth table. So what I've kind of done, I've got a little bit of a circuit here. I'm using my multimeter here as my load, I guess, because this has a battery in it. Okay, so if I come down here, I'm going to have some voltage source right here. It's my multimeter, and basically I have ran this and I've run through let's say an open push button, and then I ran through here to some load and came back. Okay, what was this load right here? We've learned that to use resistors, but really what it is, it's the horn. Okay, so when I push the button, I got the horn to work. So in the experiments that we're going to do coming up, our multimeter is going to kind of simulate the voltage source, and the load that we're going to use is going to be the horn inside of the multimeter, okay? The other thing I want to do right here real quick is make the truth table for this, okay? So the truth table looks something like this. We have one push button, and it could be the push button, and our output is the horn, okay? So the push button could be off, which would be a 0, and the push button could be on. This is for normally closed push button. So, or excuse me, normally open push button. So if we haven't pushed it, it's off, and we push it, it's on, okay? So if I come here, and I set this to continuity again, let me set this up for the normally open. There's my normally open. I'm going to set my continuity. I haven't pushed it. That means that I'm not pushing it. That means 0, and I don't have a horn, okay? Now I'm going to go ahead and push it, and that's my 1, and my horn is 1, okay? So this is my truth table for a single push button using this concept here that my voltage source is my multimeter and my push button is turning on the horn on the multimeter.